Make sure you're ready to check your warm-up at this point. So pencils down, grading utensils out. This was the last skill we learned in 3-4, so we're going to practice it one more time. You also practiced it yesterday on the 3-4 practice. So number one, when we're writing the polynomial function, the first thing is to figure out if there's any additional roots. Since this root has an I, that means there is. Since it's a 5i, that means we also have a negative 5i. So when I put these in parentheses, we have x minus 5i because it's always the opposite, and x plus 5i. Now remember, when we double distribute, we can ignore the two middle parts because they're always going to cancel out. So we go x times x, which is x squared, negative 5 times 5i, which starts out as negative 25i squared. However, remember, I squared always replaces with negative 1, which means that negative 1 will change this minus back to a positive. So our final answer is x squared plus 25. Moving over to number 2, we have negative 2i and a positive 3. Well, additional roots occur with radicals and i's. So if I have a negative 2i, I also have to have a positive 2i. The 3, remember, this is the one don't get tricked by. It does not have a radical, does not have an I, so it does not have an additional root. So we have a parenthesis of x plus 2i for the negative 2i, x minus 2i, because remember, again, they're always the opposite of the signs, and then that positive 3 has a parenthesis of x minus 3. Now we double distribute the first two parentheses. Since those are conjugates, we only multiply the first and the last because the middles will cancel. Well, x times x is x squared. 2i times negative 2i is negative 4i squared. That I squared is going to turn back to a negative 1, which will make that negative 4 a positive 4. So I have x squared plus 4, and I'm going to multiply it by the x minus 3. So x squared times x is x cubed. X squared times negative 3 is negative 3x squared. 4 times x is a positive 4x. And 4 times negative 3 is a negative 12. Look through the problem. There are no like terms, so this is your polynomial function for those roots. Here are the answers from yesterday's classwork. There was the answer key yesterday in class as well. So let me zoom in and go through this. Again, you can always pause if you need to check some of the work for a problem. So for the first two here, number 1, the possible roots were plus and minus 1 and plus and minus 2. To find the single root that does work, that's where you plug those possibilities into synthetic division. 1, negative 1 didn't work, but 2 did, so that made x equals 2 a single root. Now you could stop there because it only asked for one root. Could negative 2 be 1? It could, but I found mine, so I didn't check it. Number 2, your possible roots are the factors of 8 here, because when you divide by that leading coefficient of 1, it doesn't change anything. This one, 1, negative 1, 2 were not actual roots, but negative 2 did turn into an actual root, which is why the answer is there. Again, there were more roots that you could have checked that could be possibilities, but once I found my single one, I don't need to check anymore. Moving up. Number 3, the root that worked was 2. Here were your possible roots. 1, plus and minus 1, 2, and 4. 1, negative 1 didn't work, but 2 did. And again, it's just easiest to go in order, avoiding any fractions. The next one, number 4, there were lots of possibilities here. So I tried to organize this as much as possible. So here were the constant factors of 20. Here were the leading coefficient factors of 8. So what I did was, if you notice, 1 over 1 is 1, 1 over 2 is 1/2, 1 over 4 is 1/4, and 1 over 8 is 1/8. When I did the 2, well, 2 over 1 is 2. I don't have that one listed, which is why it's there. But 2 over 2 turns into 1, which is already listed, so I don't need to write that again. Same thing, 2 over 4 turns into 1/2, well, that's already there. And 2 over 8 turns into 1/4, which is already there too. So you'll notice that I lined them up based on which ones would be new factors, possibilities. So this one had quite a few you could have done. Again, try to avoid the fractions unless you have absolutely no other choices. The single root that I found was -4. You could also have checked 5, 10, and 20, but once you find that single root, you don't need to check anymore. So here's the synthetic division work to show you. And on 4, when I checked that one, I could tell by this number getting so big that it was not going to work. Those were probably the hardest problems of all of this. Finding additional roots, 5 and 6. Do not get fooled by that 1/3. Remember, it does not have an additional root. It's not a radical or an I. And then the last 4. Here are your answers for those. Same thing, number 9. Remember, no additional roots here, and there's no additional root for just a 5 either. So you can pause this for as long as you need to check your answers, but this is the information you need to know from 3-4. Today we're working on 3-6, which is called the fundamental theorem of algebra, and this is where we find all roots of a polynomial. We're going to use our skills from 3-4 and then our factoring skills to finish out the problems. So the first thing we're going to do is we're going to use synthetic division to find one of the roots, just like you were doing in class yesterday and for homework. Once we found that, we write the polynomial that's left, just like we did back in the first part of chapter 3. And we're going to factor that polynomial. That results from the synthetic division problem. Now, if you find that the polynomial, the quadratic is usually what we end up with, is not factorable, then you may need to use the quadratic formula. So let's look at our first problem. So we are finding all the roots of x cubed plus 5x squared plus 2x minus 8. Well, the first thing we have to do is find our list of possible roots. So we look at our constant, the -8, and factors of that. Well, we know 1 times 8 and 2 times 4. Factors of our leading coefficient is a 1x cubed, so it's a 1. So that would be plus or minus 1. So based on these factors, that means our possible roots are going to be plus and minus 1 over 1, which is just 1, plus and minus 2 over 1, which is 2, plus and minus 4 over 1, which is 4, and plus or minus 8 over 1, which is, of course, 8. So again, we're starting these problems just like we have been doing. So now we're going to go through these roots and find out a single root. So again, nothing new so far. So let's start with checking for 1. So I'm going to put a 1 in the box. Our coefficients that we need to put on here will be 1, 5, 2, and negative 8. So we bring down the 1. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. 2 plus 6 is 8. 8 times 1 is 8. So we found it right away. So x equals 1 is one of our answers. So now we write the remaining polynomial, and we did this in the first part of chapter 3. So we started with an x cubed, which means we'll write this with an x squared. So we have 1x squared, which is just x squared, plus 6x plus 8. So now that we have a quadratic, we need to factor this. So we're going to go 1 times 8, which is 8. And we want the factors of 8 that add up to our middle term, the 6. So that would be 2 and 4. So since this is a shortcut, hopefully remember that's a shortcut because our a value is 1, we can go directly to x plus 2 and x plus 4 equals 0 because we're solving for the zeros. So we go x plus 2 equals 0, x plus 4 equals 0. So what we had here was the factored form. So we have x equals negative 2, x equals negative 4, because again when you solve you do the opposite. And then don't forget, way back here we did find our first 0, which is x equals 1. You started out with a polynomial that had a degree of 3, which is why you have 3 answers at the end. Here's our second problem we're going to try, and you're going to start this problem on your own, and then you can unpause for each of the steps when I want you to get to where I'm going to ask you to. So the first thing I want you to do is to discover what the possible roots are. And then once you've figured those out, unpause this to make sure you have them correct. You were finding factors of our constant, which was that negative 5. So that would be plus and minus 1 and plus and minus 5. The factors of the lead coefficient should have been plus and minus 1. So your possible roots would be plus and minus 1 and plus and minus 5. Alright, so hopefully you got that part correct. So now I want you to use synthetic division and find out what would be an actual root. And then once you have that actual root, make sure you also write the remaining polynomial. And that's the next step we're going to check. So again, unpause the video once you've gotten to that point. If we start by plugging in a 1 for your synthetic division, we would have coefficients of 1, negative 5, 1, negative 5. Bring down your 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. Negative 4 times 1 is negative 4. 1 plus negative 4 is negative 3. Negative 3 times 1 is negative 3. That one didn't work. So now let's go over and try negative 1. Coefficients are still 1, negative 5, 1, negative 5. One times negative 1 is negative 1. Add the 5 and the negative 1, you get negative 6. Negative 6 times negative 1 is positive 6. 1 plus 6, 7. Obviously that one's not going to work. So we have a positive 5 and a negative 5 left. The nice thing here is I can erase. So now I'm going to use that same box and start with positive 5. You could do, if you had to, you could always do it on a separate sheet of paper or off to the side. And our coefficients were still 1, -5, 1, -5. One times 5 is 5. -5 and 5 make 0. 0 times 5 is 0. 1 plus 0 is 1. 1 times 5 is 5, which gives us the 0. So here was one of our answers. Hopefully you found that out. And then you were supposed to write the remaining polynomial, which should have been x squared plus 0x plus 1. Now, the 0x doesn't do us any good. And remember, I really don't want to see that. So this really just turns into x squared plus 1. So hopefully you got to that step. So now let's look at what's next. So there's our factored form. And we're going to put equals 0 because that's what we are trying to find here. Now you have a couple of different options to solve this one. This one is not factorable. So because there's only an x squared, if you remembered, we could subtract 1. So x squared equals -1. When I take the square root of it, because that's the opposite of squaring something, remember we have to put in the plus or minus. The square root of -1, well, that's equal to I. So x equals plus and minus I. Plus, don't forget, at the beginning, we also found that x equals 5 from synthetic division was a solution. You also could have done the quadratic formula, but that would have been a lot longer. But anytime you get rid of that x in the middle, if you just have an x squared, you can solve it the way that we just did here. Here is your homework for tonight, 4 problems. Obviously, they're going to take more room than what's listed between them. So you can either take a picture, write them down, or you can go back to YouTube tonight and find this video and get them from there. I will tell you that only one of them is not factorable and you would need to use the quadratic formula for. I won't tell you which one, but know that one of them is that way. You probably have some time in class, so you can go ahead and get started working on these problems.